Hey everyone, and welcome to ME 144 Heat Transfer for the spring 2021 semester. I'm Dr. Burns. So for our first lecture, what I want to do is go through an overview of this course here and what you should expect. I'm going to go through the syllabus. The syllabus will also be attached to Blackboard as well for the more detailed information. We're going to go over our rough course schedule as it lays out for now, breaking it down into 15 different modules that we'll be utilizing throughout the semester. Go over what you guys can expect for the homework, the format, and how it's going to be graded. As I mentioned, we're going to be using Blackboard this semester. And this is going to be our primary source of communication, and I'll go through that a little bit. Talk about our quizzes. We're going to have weekly quizzes that are going to be posted on Blackboard for you guys to make sure you're keeping up with the content and the reading. Go through the exact format for our homework here. Talk about how there will be a 10-point grading criteria that will be used, primarily focused on setting it up in the format for this. There's going to be 5 homework problems throughout the entire semester. Talk about exams. Exams are going to be 2 to 4 problems each. We're going to use the same standard format that we use for our homeworks. It'll be just 2 midterms for this class and no final exam. And last, we'll talk about the group project. So as we start going through the syllabus information, the class website is going to be Blackboard. So this is an online asynchronous course, and we'll get into some more details with that later. It's going to go from February 1st, 2021 until May 11th, 2021, and our prerequisites for this course are ME 143. For this course, there will be a teaching assistant. The teaching assistant is listed here. As soon as we have the office hours, these will be posted, and he will be doing virtual office hours through Microsoft Teams. This is his contact information email for now. And again, everything will be done in communication with him on Teams. He will be hosting office hours, so if you have questions related to any of the homework problems that you're working through, he will be the one grading them. So that'd be your best point of contact, is to reach out to him and meet up during his remote office hours on Teams. I will also be hosting office hours as well. If you have questions related to content, not necessarily working through your homework problems, I will be available on Teams as well. My office hours are going to be Mondays from 10 a.m. to 11 a.m. Tentatively, we're setting that for now. If I hear feedback from you guys that another time would work better, we can change that throughout the semester. But one thing I do want to stress is that I am on my computer most all hours of the day, and I'm here for you, and I understand that these remote courses are very challenging and you can feel isolated. So I just want you to know, just because it's not during my set office hours doesn't mean you can't reach out to me. Send me an email, send me a chat or a message on Teams, and I'll do my best to get back to you as soon as possible and go through whatever questions you may have related to the course. As far as the textbook goes, what I'll be using is the Fundamentals of Heat Transfer, the 7th edition. Here's your ISBN for this here. Last semester, the bookstore carried a loose leaf copy as well. I'm guessing with a lot of the remote classes, many of you won't be going to the bookstore. I chose to go with an older version just because it'll save you guys a little bit of money. Doesn't matter if you get a PDF version, a loose leaf version, a hardcover version. Any of these are fine. Even some of the newer editions will be fine. I will be posting copies of the homework, so if you don't have the exact edition that I'm using, that's fine. You'll still be able to read through all the content the same. The organization should be the same, and the homework problems will already be posted for you on Blackboard. So a brief description of the course here. What we're going to be going over in this course here is 1 and 2-dimensional steady state and unsteady thermal conduction, natural and forced internal and external convection, thermal radiation, getting into a little bit of heat exchangers and talking about boiling and condensation heat transfer. So the main thing we're focusing on within this course is conduction, convection, and radiation, and the difference between these two, and how to apply general governing equations to problems related to those. So overview here, basic goals upon completion of this course. You should have the following skills. You should be able to apply the knowledge of your mathematics, science, and engineering analysis of these new heat transfer problems, and ability to identify and use necessary inputs for communicating the heat rates and material temperatures. So that's a real brief overview of what you should expect to be able to accomplish once you've completed this course. Now, we talked briefly about the homework as well. To touch back on that, there's going to be 5 different homework assignments throughout the entire semester. All these assignments are going to be released on Blackboard. You will complete them, scan them, and submit them back through Blackboard as well at the end. All of your due dates will be posted on Blackboard. There'll be announcements and reminders as well. These are also already listed with the assigned dates and due dates on the course schedule. One thing to know is that late homeworks will lose points. Because everything is already set out for you, the dates are there, you have plenty of time to complete these. I'm asking you please complete these on time, and it's going to benefit you the most on this because that'll keep you up to date with all of your reading assignments, material, preparing for exams, and everything else. The homework format and grading criteria, I'm going to explain in a little bit here on how I will be grading these, or how the TA will be grading these based upon the rubric that I choose. Quizzes. Now, the reason that I assign quizzes is to make sure that you guys keep up with all the material in the reading assignment. So these are going to be weekly quizzes all through Blackboard. Most of them will be multiple choice, short answer, things like that. They'll give you an automatic grade for them, so you'll be able to give feedback on how you did right away, let you know areas that you need to spend more time on and work with. But really, again, just to make sure that you're keeping up with material. Because again, with these asynchronous courses, one of the biggest challenges is time management and staying on track. So I think these quizzes are going to help you do that. The quizzes will only be 2 or 3 questions at the most usually. It's all going to be directly related to either information from the lecture slides or from the textbook readings. So going back now to talk about the exams, there's going to be 2 midterm exams, no final exam. Midterms will cover material that we've gone through in the course up to each exam. Not going to be any new material you haven't seen yet before the exams. They're designed to be a remote equivalent of an in-class exam. I know that's a little bit strange right there, but I've tried a couple different ways since we've switched to remote teaching, and this seems to be the best way to give you guys the equivalent of an in-class exam. So what I'm going to do is these exams will be released on Blackboard. Typically, for an in-class exam, they'd be anywhere from an hour to an hour and 15 minutes is all you would have for these. So it'll be the same number of questions, same difficult levels as an in-class exam, but I am going to give you about 2 hours rather than the 1 hour and 15 minutes to complete it. And the reason I want to give you the little bit of extra time is to accommodate any types of issues you may have signing in, uploading things, network connection issues, internet issues, things like that. So I am giving you a little extra time, but these will be a set release time and a set submission time to complete the assignments. This is going to, again, give us the closest equivalent to an in-class exam so that people aren't chatting with each other. Again, one of the challenges with remote is that I don't have control to see what resources you're using. So by giving it the short period, 2-hour block period, this is hopefully going to encourage you guys to treat this just the same as you would for an in-class exam. It will still be open book, open note, and open, in this case here, Blackboard for you to utilize to answer these questions. Once you've completed, you scan them and submit them back through Blackboard. The format for these exams is going to be the same format that I'm going to go over for your homework assignments. There'll be nothing new as far as how you submit these assignments in that format. So grade breakdown for this semester, for this class, everything's going to be 20%. Your homework assignments, all 5 of those homework assignments are going to count for a 20% of your total grade. Your midterm exams will be 20% each. Your quizzes will count for 20%, and your class participation and group project is going to be 20%. And I'll touch a bit here on the group project after this and what should be expected for that. There are some policies I'd like you guys to go ahead and read on your own. For as far as academic integrity, please head to this link to go through that. And again, this is a big challenge now that we are remote and it's not the same as being in the classroom. So please read through this and make sure you're following all the criteria for the academic honesty and integrity. There's also a statement about alcohol and cannabis use on campus, so please read through this and understand the university's policies on this and what we expect. We also have a statement for students with disabilities, so we do have resources available. The contact for SAS is listed down here, their email, website, and phone number. Students are strongly encouraged to meet with faculty to discuss any accommodations. So if this is the case for you, please reach out to the Living and Learning Center and myself as well, and we will accommodate any needs that you have. For religious holidays, if you have anything that applies for you, please meet with me and an arrangement can be made ahead of time for any work that you may miss due to this. Any student athletes, again, if you have anything, events coming up, games, things like that, please reach out to me for any missed classes so we can make up assignments and schedule some stuff, get you the material in the right amount of time if you're going to be absent for any games or events. Course evaluations. So this is something I want to touch on a little bit closer this semester, especially with being remote. And I'm going to put up a video related to this as well. This is new times for all of us. So this whole remote learning, online classes is a different world, and there's a lot of challenges on both the teaching and the learning side of this, and we're all trying to learn through this together. So I would greatly appreciate any direct feedback you have for me of, hey, that doesn't really work. Could you please do a little bit more of this? Or I'd really like to see some of that. And even positive feedback would be great for me as well. That if something you really do like about the class, hey, I really like going through example problems with you. That really does help me with my homework, things like that. So not only the course evaluations and the official forms that go to the dean that we don't necessarily see everything of, but direct feedback for us. So if there's something you don't like or do like, we can make the necessary changes as quick as possible. Our main goal, and my personal main goal, is to make sure that you guys have all the material and all the resources necessary to learn in the best manner possible. So especially with this new times with these online learning and remote classes, I really want to make sure that you guys are getting what you need to learn the material. So I am available to you, and I do appreciate any direct feedback, be in the form of an email, a message on Teams, or even a face-to-face on Teams sometimes works the best for that, so I can really clearly understand what you would like to see more of, less of, appreciate, things like that within the course. So right here is the first draft of our course schedule. I'm going to try to stick to this as best as possible, but if you guys have questions on certain areas, and I do hear some feedback from you that, hey, I'd like to spend a little bit more time on conduction, or could we see a few more problems on extended surfaces, things like that, we may take an extra lecture to go through that, and things may move a little bit, but this is roughly going to be our schedule for the semester. And as you can see here, I have the dates for everything broken down into the individual 15 different modules here. Then the date for each of the modules here, the lectures assigned with those modules, what section it relates to in the books, the topics within the book there, when your first homework assignment is assigned, when it's due, talking about our group project and when we should start thinking about forming teams. And then we can see down here our last 3 lectures, or our last 2 modules of the semester, are going to be related to our group project presentations. And I will touch a little bit more on the group project later, but what I want to mention here for the group project is it's going to be broken down into a couple different sections as we go through it. So you guys are going to create your own problem. And again, I'll go into the details of this here, but that's basically what it's going to do is you're going to break into teams, create a problem of your own related to heat transfer. Any topic that relates to you. It could be something that you're working on independently. It could be a project for the class, something that's always interested you, whatever it may be. You guys create your own problem, your solution to the problem. Then what you're going to do is you are going to distribute these problems to other students. So the other groups in the class will each solve the problem that you create, and then they're going to submit them back to you, and you submit your solutions back to the group that created their problems as well. And then at the end of the semester, what you're going to do is you're going to create a video presentation. Similar to what you'll see from my lectures in class when I go through homework problems, you guys will create one of your own where you're going to go over your solution to the problem that you created, and we'll post that on Blackboard for all the other students in the class to see. So I think this is going to be a great way to give you a little bit more of that class interaction with other students. Even though we're in a remote class, you'll still be forced to get on teams together, work through, create the problem, discuss it, go through the solution together, talk about your governing equations. And it'll also hopefully will give you guys a little bit of input as far as when you're creating these video presentations, going through the problem of what you'd like to see. Because as you're going through yourself, it's like, hey, you know, I noticed that video over video or picture in picture or whatever it may be seems to work great. Maybe you should try implementing that in some of your future courses. So that's kind of a twofold ambition with this group project here. And again, we'll talk a little bit more in detail about that as we go on further and as the semester continues on. So now what I want to do is get into a little bit of a discussion on the homework guidelines and the formatting that I expect. So as we mentioned, there's going to be 5 different homework assignments throughout the semester. All assignments are going to be released on Blackboard. You'll complete them by hand, scan them, and submit them back through Blackboard again. Blackboard will have a rubric already there so you guys can understand how it will be graded. The due dates are all going to be posted in advance, so you'll know exactly when these are all due. So the main thing that I want to stress here is the format for solving any type of engineering problem in general, specifically now in this case for your homework and your exams. So on the top of the paper, I'm going to need all of your personal information. This is going to be important. So I know whose homework is who, and especially with the group projects, who's involved in it. So your name, what homework it is, the due date, and the class. Um, this is important here. Use only the front side of each sheet, and before we were remote, it was important because it was hard to see and make sure that all your information didn't bleed through the paper. Same type of thing now that we're scanning them back in. What I've noticed is if people write on both the front and back side of a sheet of paper, when they scan it through, sometimes it overlaps and bleeds through digitally now, and it's hard to read. Scan your assignments. A PDF seems to work the best rather than leaving it as a JPEG or a TIFF, and upload it to Blackboard when you submit your assignment. You are encouraged to work on homeworks with each other. Again, you don't have that in-person, face-to-face type of feeling that you normally would, where you can sit around in a study room with your classmates and really go back and forth and through the problem. And I think a lot of engineering is learned in that manner. You know, somebody's like, oh yeah, try this. And maybe something you drawing blanks and searching through your textbook on your own alone for hours and hours. Someone says, hey, why don't we try this within 5 minutes, and you guys can move forward. So I do really want to encourage you to work with your other classmates on your homework problems. Just make sure we're not copying each other's homeworks and everybody gets credit for what they've done here, and I'll get to that in a second here. Clearly acknowledge any help that you do get. So whether it's from the TAs, the faculty, students, or any other source, please just make a little note next to it. Yeah, I talked with Dr. So-and-so, or I met with the TA and they pointed me in this direction, things like that. Here's an example here. Mary Jones pointed out to me that I need to draw the second free body diagram paragraph, problem number 2, things like that. Just a quick note saying, hey, you know, somebody help me with this. That way, if all of a sudden everybody turns in their homework assignment and they've all talked to the TA and we see something that was, you know, very conspicuous here and it looks like everybody copied each other, but there's a note like, no, we all met with the TA and they helped us do this. Okay, that makes sense. So there's something right there. And again, please don't violate any of the academic integrity rules that we talked about earlier. So continuing on with the format for the homework here, just want to really make sure and emphasize that everything is clearly labeled. So think of this not only for yourself, but for the grader or anybody else who might be going through your problem in the future. You know, is it clear your path, your approach to solving this problem? Is it clear what your general governing equation was that you used? So this is going to be helpful for yourself as well as for the grader, and also for the grader to award you partial credit and points if they can see, okay, they clearly knew what they were doing all along. They chose the correct governing equation. They plugged in everything correctly. Everything was good. They just dropped a negative. You know, you're not going to lose that many points for it. But if all of a sudden you didn't show any of your work, you don't have everything clearly labeled, it's hard for somebody to follow what your approach was, and then the answer is wrong, then there's no real room for us to award partial credit for a problem like that. So just make sure everything's clear, neat, organized, and easy to follow. And that'll tie in down here when we talk about the grading scheme for the problems. So for both your homeworks and your exams, this is going to be the grading scheme that I have set forward here. So it's going to be a 10-point scale here. 2 points are going to be awarded for your format. So with the format, what I'm talking about, did you write your name down on the top right of the paper? Did you write out all of the given information from the problem statement? Did you write out what you're asked to find and solve for? Do you have the correct coordinate system and labels? So that's 2 points out of 10 right there, just for setting things up. So you don't even know how, you have to know how to solve the problem. As long as you've gone through and done that, you get 2 points automatically. And the reason I do this is because sometimes just setting this up and writing these down, things will click into place and you're like, oh yeah, this is what I have, this is what they're asking for. I've seen this before in a lecture problem. I've seen this before in an example problem in my readings. Okay, I know where to approach this now. So just in doing this here, it might spark something for you. The second 2 points are going to be awarded for neatness, how easy it is to follow your work. And this will be something I'll leave up to the discretion of the grader. Are they able to easily go through this, or do you just kind of scribble, erase marks all over the place, and you can't really read it? It's hard to follow. So right there, just take your time. If you need to take a little bit of extra space on this, that's fine here. And clearly label everything out. Maybe put in a little note. Hey, this is what I'm thinking here. I'm not quite sure if this is the right approach, but I chose this governing equation there. And as long as it's easy for them to follow, then you'll get there. So there's already 4 out of your 10 points just for being neat and writing everything down. The bulk of the points, the 4 points here, is did you choose the correct method for solving this, the right approach for this? Do you have the right governing equation that you need in order to solve this problem here? And if you have that there, there's 4 points right there. So right now you wrote things down, you have your givens, it's nice, neat, easy to follow, you've chosen the right governing equation right here, the right approach. There's 80% of your problem there, even if you get the final answer wrong. And that's what the last 2 points are for, is the correct final answer. And the reason I don't put a ton of points assigned to this is if you've done everything else correct and you dropped a negative or had a carry through error there, I don't want to make you fail the problem or barely get any points for it just because of that. But I do need to give some points for making sure you do stay on top of your sign convention, plugging things in correctly and everything that. So that's your last 2 points there. So this is the 10-point scale that I'm going to be using, the grader is going to be using for your homework assignments and for your exams. So now this leads us to our group project. So I already talked about a couple of reasons why I wanted to go through this group project, to give you guys that in-person feel of collaboration and working with other students, to give you a feel for what it's like to present remotely, record video problems, things like that, and maybe give you some ideas of things that could be implemented for future classes utilizing some of this new remote learning and teaching and video presentations. So with this group project, what I'm going to have you guys do is you're going to break into groups of 4 to 5 people per group. And I will encourage you to start doing this, start thinking about this now from the beginning of the semester. People with schedules, maybe somebody you actually live with and are quarantined with in your dorms or your apartment, things like that. So start thinking about some people you want in this course to be in your group together with you. What you're going to do is I'm going to have you pick a practical problem from something you've done throughout the semester, something that's interesting to you, might even relate to another class a little bit too, but focusing on the heat transfer side of it for this class here. Now, once you've picked that practical application, you're going to create a problem. This problem is going to be similar to the ones that you've seen in the lecture slides, ones that we'll go through in class, ones you've seen in your books, exam problems, and you're going to make your own up. So don't just pick one from the book and copy it. That's not what I'm looking for you to do. I'm looking for you to make your own problem. So as an example for this here, I also teach ME12 Dynamics course where we have a lot of projectile motion. So you guys have all taken that, so I'm going to use that as a reference here. So some of the interesting problems there I've seen is that a group of students in that class, back when Angry Birds came out, so you can see it was a little while ago, they created an Angry Birds problem as a projectile motion problem from class, where you have to say, okay, if I pull it back, there's going to be this force here, this angle here. What is the velocity when it reaches its peak, or where does it land if it's a release at this velocity, things like that there. So that's an example of a problem that is completely made up and not an exact copy from the book, but utilizing the principles from our dynamics course in order to create that problem. So that being said there, you will do the same thing for the heat transfer course. Pick something there. Maybe you like ice fishing and you know that there's an outside temperature that's going to be, you're going to give us in the problem statement of maybe negative 20 degrees, and you know that there's an R15 insulation in the shed, and you want the inside temperature of the shed to remain at 45 degrees Fahrenheit. So the question is, what was the temperature of the heat source inside the shed? Something like that is a great problem you can make up. You can make it more complicated. Maybe it's a double paned window in it as well that you need to work as the example problem for the heat transfer of that. So something like that would make a great problem. But again, I want to get you guys thinking about it before we even jump into the semester and the new content. So as you're looking through, reading through your problems, looking through homework problems, you might get an idea of, hey, I'd like to tweak this a little bit for my problem for our group project. So a couple more things for the group project. A diagram illustrating the problem is always great. And you can see that as we go through homework problems and example problems in the book. It's always a little bit more difficult if it's just a straight word problem. It doesn't give you that initial diagram. So I would encourage you guys to create a diagram for your group project problem there. A written problem statement that tells what's going on in the problem, provides all of the given information necessary to solve the problem. So this is the challenge with creating your own problem, is making sure that you're not taking anything for granted. Everything is there. If an assumption needs to be made, there's enough information given so that the person solving the problem can make that assumption. And I would encourage you to even say, if you're expecting them to make an assumption, put that right in the problem statement. Assume this. Clearly go through and solve the problem. So once you've created the problem, then your group is going to work together to go through and clearly solve this. So this is what's going to be used for your video presentation at the end of the semester. So make sure you clearly label what you're doing each step along the way. Keep everything neat and organized. show all your general equations and governing equations you use within the problem, explain your thought process. So this is something that you can write out, type out, and state in your video. And this is going to be related to how you're solving each individual step of the problem there. Clearly define and label your chosen coordinate system, draw any free body diagrams or diagrams that are necessary, and use your correct units throughout the problem. So this is what I'm going to be looking for when you give your video presentation at the end of the semester for your group project. So it will be graded in a couple different things. Main portion of your grade will be from that video presentation for your solution to the project, but you'll also be graded on the creation of the problem and your solution to the problem as well within that. So something to think about as you're going through the semester and you begin creating your problem there. Always reference back to this here as you start working on it to make sure you cover all those topics. So I will assign the due date. It's on the schedule roughly right now. Again, there will be set times for you to come up with portions of the project along the way, the number of people in your group, the names of your group members, what your topic is going to be, things like that will be throughout the semester. And then maybe in the form of quizzes along the way, just to keep you guys on track. Again, with this asynchronous course, that's one of the main things, is to find ways and manners to help keep yourself on track and on a schedule so you're not waiting to the last minute for completing assignments and projects. The grading criteria is going to be similar to that, or the same as that for your homework problems. And this grading criteria is more for the portion of the problem where when the other group solved the problem that your group created, you as a group will be grading the other group's problems to that. So they're going to be turning them into you via Blackboard. You'll be solving those problems or grading their solutions to those problems based upon the same 10-point criteria.